So consider this given problem statement. So it has given equation here, that is log of argument x square base 64, then log of square root of y, that is in argument, and base 8, and then 3 times log of base 512, and in the argument we have square root of y times z, that is equal to 4. And it is mentioned here that x, y, z belongs to set of positive real numbers. So in that case we need to compute the minimum possible value of x, y, x plus y plus z, right? So here, if you observe here, this 64 can be written as 8 square, and this 512 can be written as 8 cube. Why so? Because I'll try to make the base same and then try to apply some property of log so that I can resolve this as much as possible. So now in this case, if you observe, this one is the given equation, right? So this one is the given equation, that is equal to 4. Now on proceeding further, so if you observe this equation, so instead of 64, this can be written as 8 square, and this 512 can be written as 8 cube. Now in this case, I'll be applying the property of logarithms over here, right? So now I'll use a property of logarithm, that is log, and in the base if I have something like b to the power n, and let's say in the argument I have something like a to the power n. So this one can be written as, so this can be written as n by m, and this will be log of argument a and base b. So I'll be using this property to resolve this particular equation, right? Now proceeding further, that is I'll be using this property here. So if you observe here, so here x square, we have x to the power 2 and 8 power 2. So this will become 2 by 2, and this will be log base 8 and argument x. Similarly, for this one, here we have y to the power 1 by 2, right? So in this case, I'll keep it as it is so that my base remains the same. I'll not change anything here, right? Now with respect to this one, I have 3 already here, and from this 8 power 3, this 3 jumps out here, and this can be written as log base 8, and in the argument I can write square root of y times z, and this will be equal to 4. Now on proceeding further, so I'll take this and I can just eliminate these terms from here. Now if you observe, clearly, the base is same. So now I can apply sum to product property. So this will be log base 8, and this can be written as x times square root of y, and this times this particular argument, that is square root of y times z, and this is equal to 4. Now on proceeding on the further step, that is log base 8, and this will be nothing but xyz, this will be equal to 4. Now from this we can clearly mention that x times y times z, this will be equal to 8 power 4, and this can be written as 2 to the power 12. Now product is there, but the demand is of sum. So this product of three numbers and sum of three numbers. So here we can use AMGM inequality. So using arithmetic mean and geometric mean inequality. So I'll be using this. So it clearly states that, that if I have the product, that is if I have the sum of these three numbers, so I can take sum of these three, x plus y plus z, take average of this will be always be greater than equal to the cube root of this three product, that is x times y times z, and this will be taken in the power of 1/3. So this is what the AMGM inequality states. Now using this property, the known value, that is xyz to the power 1 by 3, and this is nothing but 2 to the power 12. So instead of this, I'll substitute 2 power 12, and I will just resolve this further. I will resolve this expression further. So from this we can say that this will be equal to, this will be 2 to the power 4, 2 to the power 4. And on resolving this further, we can say that this sum, that is x plus y plus z, this will be greater than equal to 2 power 4 times 3, that is 16 times 3, that is nothing but 48. So for this case we can say that the minimum possible value for x plus y plus z. So for this one we can say the minimum possible value for this x plus y plus z, this will be equal to 48. So therefore 48 is the answer to this one. So here we have used arithmetic mean and geometric mean inequality, and hence the minimum possible value we got, that is 48, and this is the solution.